This is another question about challenge set 24, inverse functions. And I had a couple of questions about from students about number 11. And it says if f of x is given by this expression, then find the inverse of f of the inverse of f of x, and the inverse of f of x. So let's just take this one step at a time here. I'm going to draw a line here, and I'm going to work problem 11 from this challenge set right here. So we're given the function f of x, and it equals 2x plus 1 divided by x plus 3. And in part A, we're asked to find the inverse of this function. So the way I'm going to do that is first I just copy the function as it is, like that, and then I'm going to switch the x's and the y's. So in other words, I'm going to switch the inputs with the outputs and the outputs with the inputs. So x equals 2y plus 1 divided by y plus 3. And now I just need to solve this thing for y. That is to get the y all by itself. Let me start by multiplying both sides by y plus 3. Get rid of this fraction. And then I'm trying to get the y all by itself. So I'm going to need the distributive property here. X times y plus 3x equals 2y plus 1. And I'm going to combine. Remember, I'm trying to get the y by itself. So I want to combine like terms, all the terms that have the y's in them. So I'm going to subtract 2y to this side and subtract the 3x over here. So x times y plus, that's a minus 2y, equals negative 3x plus 1. And let me factor the y out of the left-hand side. Looks like that. And then I can divide the x minus 2 to the other side. Negative 3x plus 1 divided by x minus 2. And that is the inverse function. And so I'm going to bring it all the way back up here. And I'm just going to write the inverse of f of x is equal to negative 3x plus 1 divided by x minus 2. So that's part A. And one couple of notes about this little derivation here. Of course, the very first step is just to switch the inputs and the outputs in your equation. And then the challenge is an algebraic challenge, really, to get the y by itself. And notice how I did that. I got rid of the fraction by multiplying by denominators. And then in order to collect all the y's together, I had to use the distributive property first to expand this thing, and then here to get the y out. So I just had one y. So that, if this is a pretty advanced little algebraic process here, so it's worth taking a look at if you didn't quite see it when you were looking at this problem on your own. But now let me turn my attention to part B. It says find f of the inverse of f of x. So part B, it says f of the inverse of f of x. And I think the result from this is going to be pretty obvious. Well, you'll see. It's really very much related to question number 1. But here we go. I'm going to start by taking f of x, because that's the function that I'm evaluating. But I want to plug this entire expression in. That is, this entire expression in for each of those x's. So let me start by just doing something like this. Okay, so this is just f of x right here. It's just this. but instead of the x's, I put these rather big parentheses because I need to put this expression in to each of those places. And I'm going to do that right here. 3x plus 1 divided by x minus 2. And right here, negative 3x plus 1 divided by x minus 2. And now again, it's just an algebraic expression that we have to simplify. Let's see what happens when we do that. This is going to become negative 6x plus 2 divided by x minus 2. Okay, I just multiplied the 2 in there. And watch what I do here. Instead of writing 1, I'm just going to write x minus 2 over x minus 2. And that is equal to 1. But look, I have a common denominator now. So on the bottom, I can do the same kind of thing. Negative 3x plus 1 over x minus 2. And instead of adding 3, I'm going to add 3x minus 6 over x minus 2. Okay? Again, I'm doing a lot of steps all at once here, but I really want to write this 3 with its common denominator. So here we go. Let me combine negative 6x plus 2 plus x minus 2. So on the top, I'm going to get negative 5x, and that's it, plus 2 minus 2, all over x minus 2. And then I'm dividing that by negative 3x plus 1 plus 3x minus 6. Well, negative 3x plus 3x is 0. Plus 1 minus 6 is minus 5 over x minus 2. So that's my denominator. Let me turn this into a multiplication problem. X minus 2 over negative 5. I'm multiplying by the reciprocal. And look at this. We get a lot of stuff canceling out here. Okay, those cancel. And this negative 5's cancel. And I'm left with x. And that is an astounding result. And let's just imagine why that happened. It's because if you take a value of x and you plug it into the inverse function, and then that gives you an output, and then you plug that into the actual function, it's going to get you right back to this value that you started with. Okay? In other words, f and the inverse of f, they undo each other. They undo all the operations that one does on the other. So you're left with just whatever you started with. So I'm going to leave it as an exercise for you to do part C, which says to find the inverse of f of x. And just spoiler alert, you should really get the same exact value that you got here. It's the same thing, but it's worth going through the manipulation of this expression because this is also a pretty complex process that we haven't really worked on since first semester.